Hello boys and girls, welcome back to another edition of Geometry EOC Excellence Television. Okay, today we are solving for missing segments of parallel lines cut by transversals. Ooh, so that is a lot. So basically what we're doing is something similar to the proportions we've been doing with similarity. Ooh, okay, so here's something you want to write in your notes along with the picture right here. I'm going to read it out and then you're going to pause the video and you're going to write in your notes, okay? The side splitter theorem states that if a line is parallel to the side of a triangle, okay, so down here, look at this. So we got parallel lines, boom. Got these parallel lines, okay, and intersect each other at two sides, okay, so here's the intersection, two sides, okay, that makes sense. Then this line divides the two sides proportionally, okay, and here is our proportion right here. So pause the video. Write this down, and then I'm going to explain what it means. Okay, welcome back. Hopefully you have this in your notes now. Okay, so it says AC, which is this. AC is to CE, right here. So these two sides, that would be to equals AB on this side to BD. Okay, so you're creating a proportion like that. So let's demonstrate what that means. No problem. So look at this one right here. So yeah, it doesn't look like a triangle, but if you extend these lines, yeah, you'd have a triangle. So it's the same thing. And I notice these are parallel. Okay, so now I'm using my side splitter theorem where I'm looking at this side. So I got A, this is A, to 20 equals, so I got A to 20 right here on the left side equals 9 to 15. See, A and 9 are in the same place, and 20 and 15. So A to 20, boom, left side equals 9 to 15. And then I just solve. Cross multiply, so I got 15 times A equals 20 times 9. So 15 times A equals 180. Divide by 15. A equals 12. Yeah, 12. Got it. So A right here is 12. Mark it up. A equals 12. No problem. That one is not that bad. Let's look at this. Whoop! Wow. Here's the next example. This is sort of like a chain reaction one. We have to do multiple proportions, okay? So same sort of thing. If we extended these, we'd have a triangle. And we have all these parallel lines, this is what these arrows mean. Okay, that makes sense. So I'm going to focus now on this right here. So I'm focused on A. See if I can get A. So I don't care about all this stuff, the 4 and the B and the 3 and the C. I'm going to ignore that. So I'm just up here right now. This is where my focus is, okay? So let's see if we can do a proportion, okay? 9 to 3. See, 9 to 3 on the left side, 9 to 3. Equals, oh, I go to the right side, right? A over 2. Yeah, you got it. Okay, let's cross multiply and solve. So I got 3 times A equals 9 times 2. 3 times A equals 18. Divided by 3. A equals 6. Yeah, put a 6 right there. Got it. Okay. One done. I still need B and C though. No problem. I'm going to do the same thing. So now I'm going to focus right here. Whoop. See this and this? So I'm coloring in blue. So that's where I'm going to focus. So my next one is going to be 3 on the left over B, still on the left, equals, now I'm on the right, ooh, 2 over, yeah, 4. Got it. So you probably look at it in your head, what is this? This is a half, right? So yeah, it's 6. But if you want to prove it by solving a proportion, you have 2b equals 4 times 3, which is 12. Divided by 2, b equals 6. Whoop! Got it. So 6 right here for b. Alright, where are we at? We almost done. Now let's look at, ooh, this side. So I can get c right here. So left side, so you got 6 over c. Right side right here, what is it? Oh yeah, 4 over 3. Okay, cross multiply and divide. So I have 4 times c equals 6 times 3, which is 18. Divide by 4, divide by 4. C equals 18 divided by 4. What is that? What is that? What is that? What is that? Oh yeah, 4.5 or 4.5. Got it. So C is 4.5. So I got A, B, and C. Awesome. Okay. Feeling good about this. I like it. All right, now let's do with variables. With variables, man. Okay. So same sort of thing. Now when I have variables, I can solve this. So in this case, AB equals, because I see they're parallel, right? See them parallel, equals BC. That's the first thing I'm going to look at. So these two are equal in this situation when I'm solving for a variable. So I'm going to write 3x minus 4 equals 6 minus 2x. So I'm going to solve that. Okay. The next thing I'm going to solve, so if AB and BC are equal, that would mean that over here on the right, DE equals, EF. On the right. Whoop. So that would be 5 over 3 y plus 1. That's DE equals EF, which is 3y. So if I just understand that, I'm halfway there. Okay, now I can solve. Let's solve this one first. Whoop! Right down the middle. Okay, so I'm going to add 2x to both sides. Add 2x to both sides. See if you can do it on your own. Pause the video, see if you can get the answer. Okay, welcome back. Hopefully you got what I got. So let's see what I got. 5x minus 4 equals 6. Plus 4 plus 4. 5x equals 10. Yeah, 5 times 2 is 10. Boom. There you go. Okay, feeling good. Feeling good. Feeling good. Ooh, this one's even tougher. See if you can follow me on this. Oh, man. So I want all the y's on one side, so I'm going to subtract 5/3 y on both sides. Write it right next to it like that. Okay. Oh, man. On this right side, I need a common denominator. What's it going to be? Oh, yeah, 3. 3. So I'm going to multiply this by 3 over 3. So that's going to be 3 times 3 is 9. 3 times 1 is 3. Yeah, 9 divided by 3 is 3. Okay, that makes sense. Minus 5 over 3y, and I can still got 1 over here on the left, because this is 0. Man, that was a crazy move. Raise your hand and ask your teacher if you're confused about that, okay? Okay, now where are we at? 1 equals, combine like terms, still y. 9 minus 5 is 4. Common denominator, slippity slide it over. Okay, how do I eliminate a fraction in front? I multiply by the, starts with R, reciprocal, yeah. Multiply by 3/4 on both sides. Why? Because 3 times 4 is 12, and 3 times 4 is 12. 12 over 12 equals 1. 1 times y is just, y. And then 3/4 times 1, anything times 1 is itself. And there you go. 3/4 equals y. There you go. When you get to geometry, you want an excellent, you got to be able to solve equations at that level. All right, let's try a few more. Here we go. Let's keep it going. Back to the original kind of problem. So here's 4 and 5. We got to do both of these. Okay. So 4, just focused on this stuff right here. This is, I'm trying to find RW. This is all my focus. So RL is 5. Boop, mark up your picture. RT is 9. So R to T. So that's this whole thingy thing up here is 9. WS, 6. Yeah. Find RW, X right there. Okay. So, I need LT. Do you know what LT is? 5 plus what is 9? Oh yeah, 4. Okay, so now I need a proportion left side here. 5 to 4, or top side, doesn't matter, equals 5 to 4 right here. I go the same direction. X over, what? 6. Got it. Okay. Cross multiply. 4 times x equals 5 times 6, which is 30. Divided by 4, divided by 4. X goes in 7 times and a half of a time. Yeah. Okay. So let's do number 5. Let's draw it in. Ooh. Okay. So now I'm here. I gotta draw another picture because I know that's all messed up. So I'm gonna draw it again. See if I can draw it just as well. Whoop. Something like that. So what's this? R right here. Draw it with me. Everything I write, you write. L right here. W, T, and S. Parallel, parallel. Okay. So I got my side splitter theorem coming up. All right. So now, focused on this, focused on this, focused on this, focused on this. Finding WS, X right there. All right, RW is 6. Boom, just kind of going backwards here. Okay, LR is 3. And TR, ooh, that's the big line segment right here, is 8. Okay, so what's LT right here? If this is 3 and this is 8, what is this? Yeah, 3 plus 5 is 8. Got it. Can you say a proportion and solve? Pause the video, see if you can solve the problem. Okay, welcome back. What was it? Oh yeah, 3 over 5 equals 6 over x. Did you get that? You should, because we've gone over a few already. So that's going to be whoop, 3x whoop equals 5 times 6, which is 30. There you go. X equals 30 divided by 3 is what? Yeah, 10. Hopefully you got that. Boom. Yeah. All right. Uno más. Uno más. Bam. Right here. Okay. Triangle M, Q, P. All right. That's what you're talking about. I got you. MP is 25. Boom. Okay. Got that. MN is 9. Whoop. Got you. MR is 4.5. Boop. Got it. MQ, 12.5. All right. Whoop. 12.5. Okay. So, what am I looking for? Determine whether RN is parallel to QP. So is it are these parallel? There aren't these lines here. So is it parallel? So I got to look for proportionality. Is there a proportion here? Huh? I don't know. So let's prove it. So in order to do that, MN over NP, these are just the proportions we've been doing, has to equal left side MR over left side RQ. If this is true, then this is true right here. Then they're parallel. Okay, so I have to prove that somehow. Okay, I can do that. So first, what MN is 9. Okay, so this part is 9. Boom. NP right here, what's this? Well, it's 25 minus 9, which is 16? Yeah. 16. Doesn't really look like that in the picture, but we're going to go with it because that's the numbers they gave us. Okay? Now we are on the left side. So we have here MR, which is 4.5, over RQ. RQ is 12.5 minus 4.5, which is 12 minus 4 is 0, 8.0. Boom, like that. No calculator involved. I got it. Okay, so is this a proportion? Does this equal this? Huh, how do I find that out? Whoop! Cross products. 8 times 9, which is 72. Boom. 16 times 4.5, you can use the calculator for that. What's that? Oh yeah, also 72. Cross products the same. So I have this is, these two ratios are the same. Boom, it makes a proportion. Okay, so I'm good. So this means that, therefore, RN is parallel to QP because this right here is true. Thank you very much. Okay, you got it. Now, flipping here. So now you see all these examples. Now you should be able to do all of them. Raise your hand if you have any questions. Great job. See you later.